the Chinese region.
Good afternoon, everyone. My name is Pao Han. I'm now operating this SK Regional Center Network China North. Today I give this talk present the architecture and the strategy and the progress of China Regional Center on behalf of my team. I mostly talk about the technical design and the plan, and we have achieved so far. Luis and Kevin has given a lot of information on the center. I don't know how much I can say. First of all, the SK is the world-class telescopes. It is an intergovernmental organization, and now it has 13 formal members. And what I want to emphasize that it's much more than just a telescope. It's a community with a shared future for our human beings. The SK include one headquarter in UK and the 2 telescope sites in Australia and South Africa, and one SK regional center network distributed in the member countries. In the German SK Science meeting, and Director of General Phil Dunn and Dr. Northern Lewis show this nice picture of the SK Science. The SK project is so important because the SK telescope will help us answer some biggest and fundamental questions in the science. This included understanding the evolution of the evolution or origin and the evolution of the universe, and understanding the gravitational wave, and even for searching for the actual terrestrial life. So the SK will provide the powerful tools we need to explore these great mysteries. This milestone has been demonstrated in Louis' report. And here now we are in the construction phase. The SK Regional Center, the deployment plan is in line with the SK of the Victory's construction plan. Now, SK Regional Center also, and now it's in the portion 0.1, and corresponding to the commissioning phase of the SK of the region, they can support the SK low and SK in future SK needs the 4 stations verification science SK. We expect to have the full scale SK Regional Center in 2030 in the cycle period. This diagram shows the data flow of SK of the Victory. It comes from the data collected in the site, load antenna and the SK mid antennas, passing through the fiber optic fibers and to central signal processor on site, and then flow into the SK sense data processor. These are 2 SK dedicated supercomputers. After that, the preliminary calibrated data are distributed to the regional centers. The regional centers, the data retrieved over 700 petabytes a year. That's in the regional centers. The data are to deep analysis and make the image and the catalogs, and that's produced for the user ready data. Since 2019, 2018 actually, we established the SK Regional Center steering community. This community is answering for the top level design for the overall requirement, the scale, structure, and the key technologies and the documentation. And after that, several years efforts, as the SK Regional Center comes into pool. Now that is the current system is called SK Regional Center. It's an important part of the SK system. The SK Regional Center is the global sense ecosystem. The important idea is the concept of the SRC net is a federated and global network of the regional data centers. The goal is to get all scientists seamless access to SK data and provide the necessary compute and the data resource. So no matter what the scientists they are, they have the same same feeling, and they have the same experience in using this data. So the overall structure, overall architecture of the SK network, SRCnet, it's designed in 5 main layers. On top of that is the user surface layer. It provides the protocol portals, and the user provide the user support channels on the help desk. And then the next is the sense platform layers that provide some necessary tools, workflow engines, and virtualization service such as the Jupyter Hub and visual astronomy. Often use the tools like the Kata or Kata of that tool. And then is the data management layer that handles the distributed storage and the data replication. So the compute and the compute layer and that scheduled the jobs on different resources like the HPC or Kubernetes, and the bottom layer is the resource access layer. It's connect the physical storage, physical compute and storage and networks, hardware instrument with the software layers. So this allows the different centers to use a key point is that all these layers using the standard APIs. So different centers use the different technologies, and they still can working together perfectly. So this milestone that before building the full system, we created a prototype network for the SRC net version 0.1. And the purpose was to test all the standards and the key functionalities. For example, the transferring the data between the nodes and the running the jobs across the network. Several partner nodes have passed the SRC net version 0.1, and we have already performed the millions of the global data transfers. And in our test campaigns, based on all this work, we expect to provide the first public access in the late 2026 to align with the AA2 construction of the SK, and in the full system rollout by 2028. So this slide shows the verification after China node passed the SRC net verification. I'm proud of that, and I appreciate all the efforts of my team. And this is confirmed by the SRC net architect and project lead. This certificate recognizes the hard work of our Chinese team and also our partner teams. In SKO headquarters technical teams. So this is the important milestone in our development. So now that we look at more closer at China SRC or CNSRC, the infrastructure is shown in this diagram. Now that we are using the cloud native architecture, that benefits from the flexible and highly highly expandable structure, and we have a tiered storage systems where you can use the very hot and can support the hot data and warm data, different layer for different processes or purpose. For security, we use the firewall and also intrusion detection and role-based access control. That makes the CNSRC is open to the international and the SKA users. So it's the compute and the data storage platform. We use the heterogeneous clusters. That means that it combines the high performance CPU and the GPUs and also support the containers. This allows us to run both the traditional HPC bench jobs and also the modern containerized workflow. The data management we have set as a URSI system. This is the standard data management system using the SKA. And the URSI provides the key features like it has a global namespace and policy control duplications that is very useful for managing the large data sets with very huge files. So this is the platform and the control layer. Platform control layer, the core architecture, we use the Kubernetes to manage the containerized microservice. That gives us benefits like the dynamic scaling and seamless upgrading. For monitoring, we use Grafana to visualize the health of our system. For scientists, we provide a web-based sense gateway and tools like Jupyter. That's very useful. So that's what very helpful for the astronomers. So this diagram shows a typical workflow. Typical for scientists using this system starts from the sense gateway and use log in the global identity service. And from that, they can discover and visualize the data and run a preliminary analysis. Once the analysis is done, that it can expand the workflow to all the system, to the full workflow. And next is get the end products. So the bottom picture it shows our China node has passed all the key steps of this verification for the FRB. SRCnet. So this plot shows the health monitoring system that can show if any component has some problem that will be quickly identified and recognized. So current state is we have passed all the version 0.1. That's we have enabled all the functionalities, basic functionalities. Then we will reach the stage to move to the version 0.2 to support the precursors data. So then I'll quickly show some past experiences of China in the SKA regional sensor network. In several years ago, in 2016, they first together with the Equal and Cismero, they provided the concept of the content-static SKA regional sensor network. That is named Arizona's. The objective is to involve industry engagement, provide personal training and infrastructure preparation, including some prototype building. And in 2019, that is the key event that we had hosted the SKA engineering meeting in Shanghai. During that meeting, we released the first SRC prototype, and this prototype has successfully demonstrated the work. So it gained the international panel's review, and and that was recognized as the first SK regional center prototype that make a great contribution to the technology, the roadmap, and prototype validations. So this our key role that has been recognized internationally, and Shanghai 2023 signed the MOU with the SK headquarters and with the Australia SK Regional Center. So with these collaborations, international collaboration, we aim to strengthen our global contribution and to support the use, provide our resource to support the region, Asia Pacific regions and the science teams. So this is the simulation, the simulated workflow that we have done. That's simulated the whole country, the SK load data and the data flow data from the data collect generation in the SK load station and calibration, the imaging process in the SDP and the data imaging in the SRC. This is a simulation work. And then this slide shows the real life. And for example, the data observed and processed, pre-processed in ASCAP data, and then the pre-calculated data are distributed to the Australia or China SK regional centers and run the data analysis workflows. And the end products are returned back to the science institutes for the users. So our next is the last slide. So our update plan that's by within 2 years that we will have this number of the compute and the storage resource that will match the requirement of the SRC net roadmap. So yeah, we are willing to build the broadcast and global influence the SK Regional Center in China to support the or community deploying the universe. Thank you.
Thank you very much, Tara. Do we have some questions? We've got a couple of minutes. Okay, I've got one then. So, Tara, how many people do you have working at the regional centre, and where do they work?
Yes, this is a good question. That is not easy to count. Not like Australia SK centers, they are centralized in the same place and in mostly in Karen's team. My own team has about 10 staff, and more work has been done by partner institute, and that will be more than 50% will involve in this project.
Okay.
I'd just like to know what the data transfer speeds are currently achieved.
Data transfer speed. Okay. So far that we have at most 10 gigabits per second between Shanghai and Perth. This is maximum availability. Usually we have regular operating is 2 gigabits per second. But by timeline, in 2026 to 2027, we aim to have 50 gigabits per second.
Thank you.
Well, that depends on the cost and the budget.
One final question from me. Do you see the China Regional Centre supporting both SKA low and SKA mid equally for the Chinese community, or do you think you will concentrate on one place or another?
And if you are talking about the SK Regional Center network, the node that will be controlled by Louis and the operation team, because the SRC net is federated network. So all the resources are shared and is managed by the SRC team. We also want to have additional resource to support the China astronomers, because we also can have some own resource to support some like Australia and South Africa.
Thank you very much, Terence. Very interesting. Okay, and so now I'm going to ask Rita up, and she's going to talk to us about the batch data processing for SKA. Thanks, Rita.
Good evening. So I will be talking about the batch processing pipelines under the data processing agent release stream, and I'll be focusing on the work that we've done as a team GUA under the STP. So I've listed the members of the team GUA over here. So I work with the and they have also attending here. And rest of the team is from the software industry partners, ThoughtWorks and the policy. Yeah, so is there a way I can see the presentation? Or
Yeah, all it says is your presentation is on the big screen.
I can't see it. So basically the SKA data processing is it's under the data processing art, and what I will be talking about will be batch processing pipelines, and will distinguish it from the real-time pipelines. So all the work that we've done under the team GUA is under the batch processing pipelines. So batch processing pipelines has been divided into a number of different pipelines. So there's the batch pre-processing pipeline, which does planning, calibration tables, aggregate of the data, and remixing. And the second part is the instrumental calibration pipeline, which does the calibration based on a calibrator source and calibration of targets using